You can have the best idea for a building, the best architectural design, the best consultant's advice, the best equipment manufacturer, installing contractor, system tuning and adjustment, and the best performer. Then, the entire result is in the hands of the operator. David Shearman began his sound career in 1974 with the award-winning gospel group Andre Crouch and the Disciples. Since that time, he's operated sound for more than 2,750 concerts and special events on all continents. In their 1992 and 93 outdoor summer seasons, David was sound director for the New York Philharmonic and Metropolitan Operas, and is currently professional audio liaison for Lone Wolf Corporation, developers of MediaLink. R. Bob Adams is a senior consultant with Hoover & Keith Incorporated in Houston, Texas. Specializing in large room acoustics, Bob works with church and religious projects throughout the U.S. His 20-plus years experience with church sound covers almost every aspect, from operating small church systems to professional recording and television production. Bob understands and conveys well the importance of the room itself to the sound reinforcement system and overall worship experience. Let's join these two top industry professionals in a live seminar where they teach, train, and talk about how to identify problems and solve them in your own church.
Where does sound start? Frankly, it starts very simply. Sound is what happens when air gets pushed. That simple statement was made by a gentleman named Dick Heiser many years ago. And the simplicity of it cannot begin to overshadow the importance of your knowing and understanding what happens when that air gets pushed around. Simply said, sound is made up of three elements. It's made up of time, it's made up of energy, and it's made up of frequency. Now, time is relatively easy to understand because when a train goes by, you hear it start, it gets louder and it goes away, but you know that the train is moving. However, sometimes you can hear the sound and you don't hear it as distinct different sounds, and it tends to slur together. An example of this is in a system where you have a long, low room and you've got ceiling speakers, and even if you said something simple like the word hello, that the arrival time lets those words get slurred together. So we address that. We address that with electronic equipment that in turn delays the signal, and then in turn we end up with all the sounds arriving at the same time frame so that you get a nice clear hello. Now, when you have this kind of thing going on, that's only one element of what's happening in sound. Sound is also made up of energy. We understand energy. Energy's volume, energy's noise, energy's loud. But energy also, you have to take into consideration, is the whisper. What happens if you don't put any energy into the sound? It's hard to hear. But if you use your diaphragm and you project or you yell, then it's easier to hear. Now, we all know that you can hear better if you yell. I mean, we must know it because this is the way that we act with our kids. They must hear better if we yell, right? Well, that reinforcement to them that comes from your volume is the same thing that we do electrically in a sound system. We're just reinforcing the energy. However, when we depend on a sound system, we have to take into consideration the third element of sound, and that is frequency. Some sound systems do not reproduce all the frequencies that you hear. In fact, some sound systems are designed not to reproduce all of those frequencies. An example of this would be a plant paging system out in a petrochemical plant or in a manufacturing plant where you have a lot of noises going on around you, but you need to pierce through that noise with just the frequencies that are necessary for intelligibility to say, fire, get out. It's a very narrow band of frequencies, but it pierces through that noise and people can hear the alert sound and they can pick up on it. The other thing that you have to keep in mind is that when you have sound, there are other things that affect the listening experience. The listening experience can kind of be thought of like a three-legged stool. You have the one leg of that stool is made up of the environmental noise. Environmental noise simply can be said everything that's going on around you outside the building if you're inside one, or outside if you're outside. It's trains going by. It's traffic. You know, have you ever stood outside a building and just listened to the traffic go by? Let me show you. Now we're standing outside a building, and we've got cars going by. Now, if I talk in a normal tone of voice, not bad when the traffic's real low, but what happens when the traffic comes by? Do you hear me? Do you notice a difference in my sound? Does it make it harder to hear what's going on? This is the kind of thing we're talking about with that kind of sound. Well, in order to stop that kind of noise, it takes structure and mass. So we build walls. That's why we build churches, so that we can keep the outside sounds out and the inside sounds in. However, if, for any reason, the structure itself is not strong enough, then the sound would tend to hit the structure, causes the structure to absorb some of the energy, and the energy passes right on through, and it comes on inside the church. Some of you have experienced that in your own churches. And it's really a difficult situation to address, because it takes mass to stop that sound and that noise from coming in. One way to address mass is to add a second layer of something to the walls. Maybe it's brick on the outside, maybe it's a second layer of sheetrock on the inside, or if it's interior walls, maybe it's 2 layers of sheetrock on both sides. One of the most common examples of an outside sound coming into a room is in the cry room in the back of some churches. Now, it's important as we go on that you remember that there's various things that a sound system operator must know about his own church. Here's a neat idea. Take a second, go to your church and build, if you will, a small diagram or just a chart of what your church is like. Then take that chart and go sit in various places in the room. Start off first with no air conditioning on, start off with no lighting on, just start off with a dry room and listen carefully to what's going on inside the room. Then, after you get an idea of where the sounds are, the outside noise is coming in and things like that, then you can take that same seating chart, turn the air conditioning system on, turn the lighting system on, and listen to the room itself and the way that the mechanical systems are affecting the room. That's very important. Another thing that's important is that you understand that these mechanical systems and the outside intrusion noises, such as the traffic noise that we demonstrated earlier, you have no control over them, none whatsoever. But what I want you to realize is 2/3 of the listening experience of your congregation you cannot affect. You cannot change them without making changes in the building itself. Another thing about your church is that each church has its own individual character. A church that is more evangelical is generally a church whose worship style is more excited and more vibrant, and people tend to get involved and they sing along. A church that is more liturgical, generally you will find that it's more of an individual leading the congregation and the congregation following, but doing it in a more quiet manner. In a church that is more liturgical, you have a major influence on the mechanical noises into the worship experience itself. So you have to be very careful in those environments. Also, it's important that you know your congregation. The people of your congregation may come from various backgrounds. They may even speak different languages. They may speak English as only a second language. Sometimes it's difficult to understand what that the English pastor is saying if you can't hear clearly in your own language. This brings up a point that sometimes in sound reinforcement, you need a secondary system, a language translation system that somebody can translate the sermon into their language. This is becoming very common today. Also, you have to remember that the age group of the people can be affected by the sound. We all know that the young people like it louder, and generally the older folks don't like it quite so loud. So if it's a loud, lively service using live music and using a band or something, then you have to understand that you may have to kind of hold it back a little bit for the seniors. And sometimes on the other side of the issue, though, you need to turn it up for the seniors so they can hear better. Again, we go back to the system we talked about for language translation. It's the same system that can be used for a hearing assistance system for those people who might have hearing loss. And one group of people that is often forgotten that's real important is you may have people in your church who have hearing loss who are not necessarily elderly. They might be young people or they might be middle-aged, and they may need hearing help. And if that indeed is the case, then make that available to them. Make them aware that it's something that they can wear and they can sit anywhere in their sanctuary. The last thing I want to talk about is the most important thing that you have to do. The one man that you must work with throughout your entire time on the mixing console is your pastor. It is important that you understand this man has the vision for the church. He understands the goals that are being set for the church, and it's his responsibility to carry them forward. You as a sound man need to understand what his priorities are. Here's an excellent idea. Get together with him and take him to lunch. Maybe you'll do it as a committee. Maybe you'll take him as an individual. That's your business. Take him to breakfast. My pastor likes to meet me for breakfast because he's an early riser also. And it's a good opportunity for us to find out the things that are important to the pastor and him in turn to find out the things that are bothering me. Maybe it's an opportunity for you to tell him that you're having a problem with the sound system. Maybe it's an opportunity for him to tell you that he's having a problem with the sound system operators. It's a time when the two of you can communicate outside the church, away from the structure, into a neutral environment, and communicate with him. You'll find out that the man cares a lot about you and he wants to communicate with you. That's real important. Every Sunday, ask the pastor about his sermon. Ask the pastor what his goals for that sermon are. He has a vision for your whole church. He has a vision that your church is following in the direction that he has set. Every sermon is a piece of that vision. There is a goal for each sermon. Talk to him. Find out what it is that he wants to accomplish with that sermon. You get in tune with him. You align yourself to his goals. The bottom line is you have to care. You've got to care, because when you care about your job and your relationship with the pastor, then you will reach a point where you will become Spirit-led and not ego-led in what you do. Keep this in mind. You can have the best idea for a building, you can have the best architectural design and the best consultant to advise on that project. You can get the best equipment manufacturer and the best installing contractor in town to put it in. You can get the best tuning and the best adjustment that it's possible out of that sound system. And then in turn, the pastor can be totally prepared. The performer can come and have practiced and rehearsed wonderfully. But the bottom line is this: the whole thing is in the hands of you, the operator. It is your responsibility to do your job right at that point.
The sound system operator has a greater responsibility, I think, than anyone realizes who has never actually had to operate a sound system. Being in the position between the worship leaders and the worshipers is perhaps one of the greatest challenges that takes place in the service, regardless of what type of denomination, what type of church building you're in, what type of sound system you have to work with. And we'll sequence through, starting with a very simple sound system, and we'll learn about how things begin to get more complex, and we'll look at some of the different things that you need to take into consideration as a system operator. Bob has pointed out that 2/3 of what the congregation is hearing are happening before you've even turned on the sound system. No matter what you do with your controls, no matter what type of equipment you have, if you don't address the environmental noise, the grounding loops and hums and buzzes that can take place from related equipment, from lighting systems and such, it doesn't matter what you do at this point, you're not going to solve those problems with the sound system itself. But let's think for a minute about the sound system. Sound system control is going to take place at a certain spot somewhere in your church building. It may be in the seating area with the congregation. It may be stuck off in a little sound closet that got designed in 1959. It may be up in a large, spacious technical production facility in the balcony. There are a lot of variety of ways that this could happen. But wherever you're operating your system, and whatever type of system you have to work with, the input side of the system is going to take into effect everything that's being put into that service by the worship leaders. It starts by picking up sound with microphones of different types. Later, we'll examine a few different varieties and what they're used for. It might be the pastor's microphone, and this might be one. It might be 2 or 3 different mics at a podium or at a lectern at different spots at the front of the church. It might even be a wireless microphone system that your pastor prefers, or that you as the sound system operator have steered your pastor towards. You have choir microphones to deal with sometimes, and depending on the architectural layout of your church, where is the choir physically located, how well is what the choir is doing coming across to the congregation, and what types of microphone techniques are going to be needed. Each one of these questions, the sound system operator is responsible for thinking about ahead of time, knowing how to deal with them in real time, both in rehearsal or in the pre-planning and in the service, and then knowing how to discuss what happened with the music director, with your choir leader, with your participants in the worship service. You may have instruments of various types. The piano and the organ are very traditional and are often found in most churches. You may have a pipe organ. This pipe organ may possibly have a sound reinforcement system attached to it. Your church may have an acoustical environment that doesn't require reinforcement for the pipe organ. Each one of these aspects is on the input side of your system. The sound system operator is stuck or positioned at that spot between the inputs and the outputs. When we say output of the sound system, we're talking about the worshipers, the attendees, the congregation, the people who are positioned in the seating area and are listening to what you, the sound system operator, are creating. What you're adjusting, what you're listening for, what you're having notes that you've made ahead of time, all of these parts, you're mixing that blend of those inputs and you're creating an output or separate outputs. In a few minutes, we'll look at some of the different ways that a sound system can become more complex when you need to use multiple outputs. But for now, let's think of some things. The mix outputs, the actual master fader on your mixing console, that's oftentimes just the beginning. You may need to split that signal to a tape recording feed. You may have other media facilities in your church where your sound is affecting what goes on to a radio broadcast. EQ units. EQ stands for equalizer or equalization. On each of your mixing board outputs, you may have a separate equalizer. In the rack beside me here, I have a couple of graphic equalizers, and later in the program, we'll learn how to use them. Crossover, an electronic crossover. What does that do, and what does that require of you, the sound system operator, in terms of knowledge? As we learn in a few minutes about the audio frequency spectrum, the high frequencies, the mid-range frequencies, and the low-range frequencies, we'll see why the crossover can become important, splitting the signal between the lower components and the higher components. And in your church's sound system, as it moves from the simple to the more complex, you may have to learn about this piece of equipment. The amplifiers and speakers themselves. What you're doing here on the mixing console is being fed or distributed through signal lines, but ultimately you're going to have some sort of power amplifier section that is sending that signal to the loudspeakers and driving, reproducing that sound. This is where your primary energy comes from. Now, let's think about a simple sound system. Most of us who've worked with a sound system, who began learning on something small and simple, are familiar with this format. A powered mixer, where it's actually a mixing panel of some sort with built-in amplifiers instead of the discrete individual power amp units like what we have here. The powered mixer and perhaps a small pair of two-way speakers on tripods. This is oftentimes the first exposure many of us have to a sound system. And in many churches, especially new congregations, startup churches, satellite congregations that are set up, this small, simple system is often the first way to reproduce sound in a church service, and it's oftentimes the first thing that a beginning sound system operator gets exposed to. The only problem with sticking to this format is you have limited resources. If you're going to make the best investment possible for future growth, both of your church's congregation and of your sound system as it gets more complex, you're going to need a way to interface with some of these more professional components, like the power amplifiers, the delay unit, the graphic equalizer, and other things. Before we get into thinking about the actual equipment that one would use in a sound system when it begins to get more complex, it's good to understand the idea of gain structure. Gain structure is a term that lets the sound system operator keep track of the signal flow all the way from the input side, the microphones and things that we spoke about, through the mixer, the actual mixing panel that the operator is controlling, into things like the equalizer, the crossover, if we are splitting the signal between the low and the mid-range and the high-frequency components, and the power amplifiers, which are actually driving our loudspeakers. At the top end of each section there, you see a lighter shaded area that says overload. At the bottom range of each section, you see a darker shaded area that says noise floor. What do these terms mean? The noise floor is the internal circuitry noise that each piece of equipment is going to add to your signal as it passes through, as it ramps up through this gain structure. On the upper side, the overload area, or the term you may have heard clipping, this refers to the distortion that can occur when you overdrive the electrical circuit in a particular piece of equipment. So that you can see, starting with the microphone, with its very small, minute output measured in millivolts, passing through the preamplifier section, what we call the input module, that we'll learn about in a few minutes, going on through the output section of the mixer, passing through the other pieces of signal processing, on through the amplifier section. The sound system operator has many points to be aware of. And if the end result of the sound that you're creating has too much hiss, background noise to it, you're probably down in the noise floor of one of your components. If you have too much distortion or fuzzy sound, you're probably hitting the input side of one of your components a little too hard and overdriving it or overloading it. So our goal, by the time we've passed through all of the different electronic components, is to have the cleanest possible signal hit the power amplifier so that the input signal measured in volts that comes from the power amplifier can be amplified. Because if we're amplifying a dirty or a distorted input signal, it's just going to be louder. The amplifier doesn't clean that signal up. And the problem in many church sound systems is not the amplifiers themselves as much as it's the distorted or the low-level input signal that's reaching the amplifier section. So the sound system operator's ability to track the gain structure of your own church's sound system, and this can often start by learning about each piece of gear, and if no paperwork or documentation exists, perhaps you can be the operator who starts that. What is the signal path through these different components, and how does it get to to the final output stage of the system. To most sound system operators, the piece of equipment that is focused on the most is the mixing console, the mixer, the console. A different term might be used by different people, but we're talking about this piece of equipment. There are four main ways that we can look at this mixer to understand its controls and what they do. Four basic features. The first are the input features. What part of the mixer is available to me, the sound system operator, to adjust or to manipulate those input signals, whether it's the pastor's mic, the choir mics, a contemporary musical group, maybe it's a playback feed from a tape deck or a compact disc player. How can I, the operator, control those inputs? The second area is the routing ability of the mixer. How do I decide where to send those signals? What do I plan ahead of time? Or in many instances, what way of doing things have I inherited from a previous sound system operator, or perhaps from a designer who's not familiar with my church and its needs? How do I route those signals? On the mixing console, we have usually a section that lets us assign that input signal to the different auxiliary or utility or effects buses. That's one area. We have subgroup assignments that we can decide to put these together in groups, which leads us to our third category, grouping. How well is the system operator able to group the different input signals and then work with those groups so that perhaps 6 different microphones can be controlled with one fader on what we call the subgroup. The fourth category, we've already talked about the input and the signal flowing to the output. Fourth category, the output section of the mixer. It's usually over to the right-hand side of the mixer. The signal is flowing from left to right in terms of how we think about laying out our microphones, our controls for each microphone. The output section is usually the farthest thing to the right there on the mixer. Let's look in more detail at each of those 4 sections. By the input section of the mixer, we're referring to the vertical strips or rows of controls that are above each fader. The fader is the largest knob or control typically found here on the bottom of the mixer. The vertical strip and everything associated with it is related to whatever we're going to the signal connected to that input module. For example, input module number 1, connector number 1 on the back. Every control here is related to what we're going to do with the signal on that input. First thing we decide is, are we going to have mic or line level present? A mic level signal, what's coming directly out of the microphone, that low measured in millivolts signal that we talked about in our gain structure, that signal is going to have much less energy than a line level signal or a pre-amplified signal that is coming perhaps from a synthesizer, another mixing console's output that we're feeding into this board, a variety of reasons that we might get a line level signal. The outputs from a reverb unit, for example, would be line level. We need to determine that that signal is present. We test by some way, either by an indicator light on the mixer or by checking with the Q or the solo bus and then looking at the meter. As up here we can see my voice on this mic appearing on the Q meter. The next thing we look at is the preamp level. The input attenuator, usually the top knob or control all the way up here on the upper end of each input module. We set the gain or the level of the signal that's coming into the mixer. Just like a water faucet, we decide how much signal flow are we going to let into the mixer. That's what the preamp gain control is for. Most mixers will either have a pad something that will let us cut that signal level perhaps by minus 15 or minus 20 dB when it's a hot line level signal, or a pad can be taken off when it is the mic level signal. In determining the tonal quality that's desired for that input signal, we have what's called the EQ, or the equalization section. This is usually a row of identically colored knobs grouped together where we have our lows, our mids, and our highs that can be adjusted separately. The next thing we look at is where do we want to assign that signal? In our routing section, we need to decide where to send the signal. Should it go directly to the masters, to the main output levels of the mixer, or should it go to a subgroup? If it needs to go to a subgroup, we can do that assignment here in the grouping section. On this particular mixer, when we engage the switch that says 1 and 2, this input signal is now going to groups 1 and 2 on this mixer. The grouping ability on a mixer is important whenever we need to take things like choir microphones, musical instrument microphones, or perhaps several different pulpit microphones, and use one fader or one control, one group fader, to handle all of those microphones that we've selected to that group. The fourth and final category on our mixer is the output section. We typically will have a left and a right master output for the mixer. Sometimes we can choose, depending on the features of the mixer we're using, to depress a button here that says stereo and send this input module's signal directly to the stereo outputs. If we take it out of stereo, here at the input, this input module is no longer sending its signal to the stereo master outputs. The matrix output section is where we can send a signal to someplace else other than the main left and right or the groups. We can mix and match different levels from the group and the master outputs and determine which one of those signals need to go to an auxiliary output. We'll learn why that's important in just a few minutes. Let's go back to thinking about that simple sound system that we first looked at. You can see now that I've opened the system up. Instead of having a single powered mixer with the amplifiers built into this mixing panel, I've decided to think and to plan for the future expansion of my sound system. Or perhaps with the sound committee and other persons in my church, the music director, the financial committee, I've determined that what we have is not adequate for what we need in our service, and I need to expand the system. If I have chosen properly a mixing panel or mixing console at the very beginning that lets me expand the system naturally by interfacing with discrete power amplifiers, I've opened the system up in terms of possibilities. The first thing that happens when we go to a more flexible mixer is that we have more patching points. We have more input and output patching points because something the same size, instead of tying up all that real estate on the back of this mixer with the power amplifiers, it's left room for more patching ability. So we take those additional outputs on the mixer and we start thinking about what are the different ways we need to add something in our sound system. What can we do to give more control to the mix that we're creating here and distribute it to our congregation, to our listeners? How can we better take the input signal of the worship leaders and control and then distribute that to the service itself? When we move beyond stereo to more complex output distribution schemes, it's going to take even more amplifier channels to accomplish that. The first thing that really gives life and body and fullness to a sound system is to add the subwoofers, low-frequency components. That usually takes another discrete amplifier, and the system here in this room you hear the low-frequency sound, and at this point is a good time to discuss a common saying that low frequencies are omnidirectional. What does that mean? Low-frequency sound will go just about anywhere in the room, and it doesn't really matter where the speakers are located. The low-frequency speakers that you're listening to are just right up here under the table. They could be over against the wall. They might be installed up in the ceiling mechanicals. The point is that the discrete subwoofer or low-frequency component to the system, when it's gone, makes quite a difference. So the design of the system in your particular church, when you start thinking of ways to expand the sound into other areas, the subwoofer section is one that you may hear discussed by a sound system consultant or an installation contractor, or perhaps by someone working with your church on the design of the sound system. Without that subwoofer, you're not going to get that type of full-bodied sound, and it takes the careful application of the subwoofer to the system to accomplish optimum results. Now, what is it that makes low-frequency enhancement or the use of subwoofers so effective? We can see that the subwoofer system is going to require a separate power unit or a separate power amplifier. It's going to require a crossover unit that we discussed earlier, some way to define or to shape the sound so that it's optimum for the subwoofer. We hear the sound without it, and we see that everything below about 80 cycles or 80 hertz is missing from what we're hearing. We add that sound to the room, that lower 2 octaves, that bandwidth or that frequency section is what we want to be sending into the subwoofer or into the low frequency system. Without that, without those lower 2 octaves, we don't have the ability to move air. And Bob told you earlier, sound is what happens when air gets pushed. The subwoofer, with its larger speaker cones, is able to push more air. So quite simply, with the addition of the subwoofer, or the VLF, the very low frequency system, we're able to give the attendees, the congregation, a sense that the air around them is being filled with more energy. Depending on the type of program material that you use in your church worship services, a subwoofer system may or may not be appropriate. Another good way to expand your sound system is to add additional speaker locations in other parts of the listening area. We can call that expanding the sound system by adding delayed speakers. Bob told you earlier a little bit about the idea of sound system delay or time delay, signal delay. What do we mean by that? Well, to incorporate a technique like this, we would first of all need to have the more flexible mixer with the signal routing abilities to feed additional buses or additional outputs that can be used for rear-located or under-balcony or side wall type speaker locations so that we have control at the mixer of that additional part of the system. We might want to have that control be in our signal processing rack. But when we add speakers beyond the traditional central cluster or just a left and right format for our speaker system, we're going to have to get into the idea of delaying the signal or delaying the time of the signal. Let's see what that might sound like. We'll start by listening to the sound of the system just in the simple format with just the front, left, and right. So you folks here in the room are hearing the front system. If I add the rear system, you hear the sound come in behind you. But I need to make sure that my signal delay unit, my time delay adjustment unit, is set properly. If this delay unit is improperly adjusted, hear how the sound is now staggered, the sound in front of you and the sound that is coming from behind you. It's arriving at your seats at different times. When the sound is adjusted properly with the delay unit, it appears to arrive at the listener's seats in the middle and the rear of the seating area at the same time. How do we accomplish that? The effective use of signal delay for time synchronization requires, first of all, the physical location of speakers that are along the sides or in the rear of the seating area. So that is often called a distributed system, a rear fill system, a surround system. It might be referring to the speakers that are needed underneath the balcony in your church if you have a theater-style church. Those are the speakers that we're going to have to delay the signal to. We're going to have to delay the time arrival of the signal to those speakers because they're closer to the audience, they're closer to the congregation seated there than the speakers that are up near the front where the pastor is located. The main way to do this effectively is to use a simple rule of thumb. We don't have to know how many feet per second does sound travel. We just need to know that 1 foot of distance from your front speaker system to your back speaker system, each foot of distance is going to equal approximately 1 millisecond of signal delay on your delay unit. 1 foot equals 1 millisecond. This rule of thumb is good up to about 100 feet. If the distance gets beyond 100 feet, we have to do more precision calculations, and the design of that system would probably be best left to a qualified sound system designer. But up to about 100 feet, 1 foot, 1 millisecond, will let you synchronize this front and this rear located speaker system so that the addition of units in the rear of the hall or along the side walls or overhead can be time synchronized to the sound coming from the speakers at the front of the room. Another area that we want to talk about when discussing adding to your sound system control is what we call signal processing gear, signal processing equipment. What does that mean? Signal processors could be termed any device that we use to shape or adjust the sound signal before it gets fed out to the loudspeaker system. Typically, that would mean an equalizer. The equalizer is a device that works with what we call the audio frequency spectrum. What does that mean? 20 to 20,000 cycles, or the abbreviation HZ, which stands for Hertz, an esteemed European physicist from several hundred years ago. 20 Hertz to 20,000 Hertz, or 20 cycles to 20,000 kilocycles, KC. How does that relate to me, the sound system operator, and to what your parishioners, your congregation, your worshipers are going to hear? How does one know what to adjust on the equalizer and why? In working with church sound systems, there are 2 very easy and simple methods to familiarize yourself with the audio frequency spectrum. The first one is start with what we call concert pitch, A440. A440 that your choir director or your pianist or your church organist is familiar with is the same 440 cycles or 440 hertz that you, the sound system operator, is going to be working with on this equalizer. 440 hertz on the piano, concert pitch A on the keyboard, is the same tone or the same frequency as 440 cycles on the equalizer. Another way to become familiarized with the audio frequency spectrum is to think in terms of lows, mids, and highs. And I use the choral group, the choral ensemble, with its bass, its tenor, its alto, and its soprano voices, to think about how to best work with an equalizer in a sound system. Your low frequencies, of course, are going to be your bass voices. And typically, up to about 200 cycles, 200 hertz, that is the realm that we call low frequencies. The mid-range frequencies that pick up where our tenor voices are and move up through our altos and into the lower range of our sopranos are going to go up to about 2 kilohertz, 2,000 cycles per second. So the 2K right here on the equalizer is going to be similar to or analogous to the voices, the upper harmonics of the voices coming from the soprano vocalists. The high frequencies, you can see, are beyond the fundamental frequency of even our soprano voices. Even our best soprano soloist in the choir, when she hits her highest note, she's just getting into most of what goes on up here on the equalizer, 3,000, 4,000, 5,000, 8,000, 10,000, all the way from 2K up to 20K. Most of that is not tone in the voices or in the choral ensemble. It's breath. It's sibilance. It's articulation. It's all upper harmonics. And so trying to grab the sopranos by doing this is not going to bring the soprano voices out. It's just going to put a higher voltage level into our high-frequency components in our sound system with any sound that's passing through the electrical signal going through this device. So becoming familiar with where your choral voices are and where A440, concert pitch on the piano or the organ is, that's one very good way for the sound system operator to begin to understand what can be a very confusing device, the equalizer. Learning about the microphones, their different types, styles, and the application, how to use them, is one of the best skills that a sound system operator can assemble in your toolkit. We're all familiar with a basic microphone. We can look at it and say that's a microphone. We know which end to plug the cable into, and we know which end to tell the pastor to speak into. But what is the actual nature of this device? Remember, when we talked about gain structure, we said that a very minute signal measured in millivolts is coming from this device. What characteristics does it have in terms of its frequency response, its pickup pattern, its voltage level? Is it a sensitive microphone, or is it not very sensitive? Is it going to give us a hot signal right from the capsule? All of these different things can usually be found in product specification sheets from the chosen equipment supplier that you use for your microphones. The most basic type is called a cardioid dynamic microphone. Cardioid, so called because the heart-shaped pickup pattern of most mic elements of this type. Dynamic, meaning it has a moving coil that responds to the air pressure hitting the coil, and as this moving coil goes back and forth, a minute electrical impulse is created, measured in millivolts, which goes down the microphone cable. The dynamic cardioid microphone is good as a handheld vocal mic. Having good quality mic clips is important. If your mics are taken off stands by vocal soloists or by a contemporary music group, this is something you probably want to have a good stock of in your church sound system. More specialized, this is a CM310. This particular manufacturer, Crown International, markets what they call the differoid. This microphone is a hypercardioid. Hypercardioid means that the pickup pattern is tighter, so that a person who were off axis like this wouldn't be picked up as well, and the hot spot or the pickup zone for this microphone is here. It's not optimum for someone who has poor microphone technique like this, but in a noisy environment, perhaps being used by a vocalist with a contemporary music group behind them, this would be an excellent choice because of the tighter pickup pattern. And remember, microphones are not very intelligent. Just because we label Susie's voice or tenor soloist here on the mixer, that doesn't mean that's all that's going to come down the line when we raise the input fader. That's up to us, the sound system operators, to pick the right microphone, locate it properly, help train and assist in educating the person that's going to use the microphone. All of that falls into the realm of your job as a church sound system operator. What do we do about the pastor? That's always a question. Typically, a pastor or a minister or any worship leader who likes to talk from a fixed position, perhaps standing up at a pulpit or at a lectern-type wooden device, is going to present the sound system operator with some challenges. The first one is, how do I pick up the voice when the person drifts on and off the mic, when the person is far away and then leans into it? What do I do about all the extra sounds that are coming because it's a pulpit? A pulpit is a hollow wooden box in most churches. It's just an untreated, unthought of device that you're attaching a microphone to. This is a gooseneck or a mini flex type microphone. This is an LM300 from Crown International. This mic is what we call a miniature condenser mic. Condenser, as opposed to the dynamic type, the condenser mic uses a pre-polarized voltage that's coming towards the microphone over the mic cable, and this allows the construction of a smaller, more delicate diaphragm or moving surface in the microphone so that that type of high-frequency sound and the articulation required, especially by a public speaker who may not always be the same distance from the microphone, the condenser-type microphone will help pick those sounds up better and let the operator have a more natural and consistent sound here at the mixer. So an integrated package that has an ability to position the microphone, the user himself or herself can even use it. Noise-free type operation, hopefully. Something to look at carefully when selecting a microphone like this. The mechanical handling noise itself. Some sort of pop screen or wind filter that lets us not pick up those type of sounds. A well-designed microphone package for the pulpit would have these features. Another type of microphone along the line of a miniature condenser element is this. This is a very good problem solver for perhaps using on an acoustic guitar in a worship service, perhaps being positioned in an area where you have a flute player, a flautist who comes on. Any place you need to pick up good, high-quality sound and have it hidden from view or not be an obvious type of distraction visually. What about the choir? What do we do about the choir? This is going to depend on several things, and Bob's going to tell you in a few minutes about how architectural acoustics influence the sound of your choir. But right now, from my perspective, as we talk about the sound system operator and how he or she has to live with architectural acoustics, sometimes it's important to be able to pick up sounds over a wide area. And a microphone of this type, a boundary layer microphone that is intended to be put on a flat surface and then will pick up sound. If this were mounted on a table and we had a panel of 3 voices talking, something like this is a good way, a good general way to pick up all of the conversation at that table and get that into the sound system. The PZM type, pressure zone microphone, that takes the same sort of miniature condenser element and has a built-in flat panel or flat surface that actually couples that mic element to a larger surface like the foot of a stage. Perhaps you have a children's program and 3 or 4 elementary-age children whose voices need to be picked up. We don't go sticking lots of a clutter of microphones and booms and things out there, and we don't want to take several $1,000 wireless mic systems just for the kids here. But one microphone of that type in the area where they will be during that program is a good way for you, the sound system operator, to get that input. The final thing I'd like to talk about as we discuss microphones and their applications is the wireless system. The first thing to remember is even the best RF system is almost as good as a microphone cable, meaning no matter how expensive that wireless microphone system, we still are susceptible to certain possible problems because of the use of radio frequencies. Any sound system operator who begins to have to start dealing with a wireless mic system has 3 specific things to take care about because it's not just a traditional mic anymore. The first is that it's battery powered. What the person actually holds in their hand or wears, in this case, what I have is the transmitter, and it's in my pocket. The battery is inside the case here, and there's not even a transmit antenna visible. The second thing is that gap between the transmitter and the receiver. There is no wire. And because that's a radio frequency link between transmit and receive, you're now possibly susceptible to outside interference. This particular element that I'm talking on in this wireless system is tiny. The parts are hard to replace. The wire and cable itself is thin. And while this is a very good system, I'm just pointing out that the third aspect that the operator needs to keep in mind is the more fragile nature, typically, of the wireless system. The receiver part of the wireless microphone system is something that deserves special care and attention. Depending on which system you choose, you're going to have to carefully position your antennas. You're going to want to make certain that they're not susceptible to being bumped or readjusted by people who happen to be passing by your sound booth area. You're going to want to pick a spot that is accessible for service and for turning it on and off and for making adjustments, but something that also is not going to give you interference from other electrical equipment. Now that we've talked about all the different types of microphones there are that can be used during a church service and all of the reasons that we might start expanding the number of inputs here, we should probably address a subject that usually comes up, especially if you have a contemporary music group or some sort of musical ensemble that is part of your worship service. And that is, I need a monitor. I can't hear myself. When I'm playing or singing, I can't hear what I'm doing. The idea of a monitor, a separate speaker for a performer or someone who is speaking or creating music during the service, it's a very touchy subject. The more monitors you have and the more different locations there are for these small speakers, similar to what we have here, one tiny slant monitor speaker. Very modest thing as a monitor system, but let's see why we have to carefully consider every time we send signal to one of these, and we have to be very careful about where we place them. Right now, we're listening to music through the main sound system here. During this delicate passage, let's pipe it into the monitor speaker. Now, from the perspective of you sitting out here, if you're the worshipers, you can hear that sound bleeding through to your seats. And we're in a fairly small space here with a small speaker, but the effect is the same. The more that we add the sound to the monitor, and then take it away, the more it affects what people can hear in the seating area. We have to carefully think about what signal we're going to put into the monitor speaker. We have to carefully think about how many are really needed and where should they be located for two reasons. First is a visual reason. If we start setting 10 and 12 and 16 of these things all around the front of the church, things can be pretty cluttered. Secondly, for a sound reason, and that is each time we add another speaker on stage or at the front area of the church, near the pulpit, near the choir, we're putting a sound-generating device into what's usually a fairly live or reflective surface area. A choir loft that is behind the pulpit at the front of the congregation is a very reflective space, typically, and the more monitor speakers we put on the front part of the church, the more sound we're introducing into that part of the church that is not intended to be heard by the congregation. We've talked some about what the things are that the sound system operator for a house of worship needs to take into consideration. And we've talked some about expanding or reconfiguring the sound reinforcement system so that the sound system operator has a greater amount of control over the input signal and is learning how to distribute the outputs to the different parts of the system as best suits your congregation and your particular church. As we move beyond the basics and get away from simpler sound systems like this, the very same techniques that we've learned about here are called into play. You may need to learn how to take these simple skills and apply them on a larger scale. Perhaps your church is going to do a singing Christmas tree event during the holiday season with 200 voices. These things do start to come up, and you, the sound system operator, are who gets asked to start thinking about the planning of this event. I'm going to show you two separate examples, and we'll look at the first one here. We talked about the idea of the delay speakers being used just within your congregation. Here's an example of a delay speaker tower set up outdoors at an event. There were more than 250,000 people at this particular event, and it took several dozen delay speaker locations like this one you see with scaffolding and a speaker stack laid out all throughout the audience area. The signal delay units are the same as what we've discussed here in this tape. The adjustment of them is the same type of technique. The same skill is required to understand about the arrival of time, and the same ideas used in the congregation, the smaller sanctuary with rear located or under balcony speakers get used on a larger scale for much larger sound systems. Learning about these techniques now is what prepares you in the future and helps you to educate younger members of your congregation who become interested in the sound system about how to work with these principles. We've talked about microphones and picking up the sound of the choir and that sort of thing. Here's a 450-voice choir with a 250-piece orchestra in front of it, and the pulpit with the microphone over there to the left is actually reaching out to 500,000 people. This is the papal mass with His Holiness Pope John Paul that took place during the summer of 1993 in the state of Colorado. In working on this event, the sound crew, the technicians, and us operators had to use the very same ways of thinking about sound that you need to use each Sunday morning as you carefully adjust, as you select your equipment, as you position your microphones and your speakers, because your simple sound system can easily move over time to a medium range or a mid-level sound system and then turn into a more complex system. And you, the operator, take those tools or those skills, those techniques that you've learned, and you apply them in the future to larger projects. You become the in-house resource or the knowledge base for your congregation and your pastor and your music director to rely on. We've seen how we can go beyond a simple sound system and take the basic skills, the same things that you as the sound system operator are learning now in your situation. These same skills become a foundation that you apply to larger and more complex situations, like we've just looked at. As the sound system itself becomes larger and more complex, we have to add more power amplifiers. We have more gain stages to deal with. And the control and monitoring of those gain stages can become a critical issue. This is often a part of the sound system that's hidden from view from the sound system operator. When a personal computer is linked to the sound system, a new level of control and monitoring ability is reached. This particular system is the IQ system from Crown International. Computer linkage represents the leading edge of sound system technology today. This is particularly relevant in larger churches and buildings that have complex geometry, especially the fan-shaped churches that are often constructed. Bob's going to tell you some about that in this next section on architectural acoustics.
We've spent time now talking about the responsibility of the operator to understand the pastor, his relationship, and to take a look at the things that you can't affect. Now we're going to talk about a little bit of the architecture itself, how sound reacts inside your space. I realize that you may or may not have a rectangular room, you may have a fan, you may have a room with a high ceiling or a low ceiling, and all of these architectural parameters affect the way sound travels in your space. One of the most common problems that you run into is a type of sound called a flutter or a slap. And it happens like this. As you look at this drawing, you see that we've got a nice little rectangle room here that we used as the model for our taking down the positions earlier. And now we've seen that we've got a sound that originates around the pulpit. But the sound has traveled to the back wall and then turns around and comes right back at the pulpit. Now, for sake of example, I pulled the lines apart just a little bit so that you can see them. But in reality, if the walls are perfectly parallel, it's going back and forth perfectly. And it's going to do that until the air itself actually absorbs the sound energy and the sound is said to decay. You can see the exact same thing can happen from side to side. We would call this a sidewall flutter. Now, you really can kind of deal with a sidewall flutter. It's not really good, but if you have to have one, a sidewall flutter is a little bit useful as far as congregational singing is concerned. The people sing, the sound travels between the walls, and it kind of adds to their image of the sound that's going on, and sometimes you can deal with that. It can get exaggerated, and when it does, it becomes a real problem. But the major flutter that you have to deal with is the one that travels from the rear wall back towards the pulpit area. Now, if we're dealing in sound reinforcement, our angles are such that the speakers may be up and they may be aimed down, and when that happens, the sound goes down, but it also goes down and hits the floor, so it doesn't return. But the energy that you must keep in mind is the energy from the choir. The accumulated energy of the choir, when it sings, creates one sound that travels as a wave back to the back wall. That in turn hits the back wall and comes back to the choir, and now it is an added energy to the original next source, if you will. If you want to think of it as two different notes, one goes up and comes back, and now the second note is starting. And what happens is you get an accumulated energy of the choir at one location. This means that you can have twice as much energy at the choir than you think you have. And in turn, when you try to reinforce that, it can be a very serious feedback problem. So it's something that you have to deal with. How do we deal with it? The most common and simple way to deal with it is to simply put absorption on it. We can have a picture here of a balcony face, and you see the same thing here. We have a sound reinforcement system. The sound is going out and hitting the balcony, and it's coming right back, in this case, to the pastor because of the angles. But watch what happens when we put absorption on the face of the balcony. We reduce the amount of energy that returns to the pulpit. Well, yes, we do. However, we reduce it only in specific frequencies. The absorption material that goes on balcony faces and that's generally used as absorption, it has a limited amount of effectiveness in the lower midband and in the lower frequencies. In the upper midbands and in the higher frequencies, as we discussed earlier, absorption works fairly well. The problem you have now is that the dotted line represents that the low frequency energy coming back, and let's say you started off with a high frequency feedback pitch. Now you have the potential for a low frequency feedback pitch just as strong because it becomes the primary wavefront. So there's really something else we ought to do. What we ought to do is try to cause that sound wave to go somewhere else, to go and be used somewhere else maybe. So we can change the face of this balcony to where the sound wave is broken. Part of it goes up and it hits the ceiling and gets lost up there. Part of it returns down immediately to the floor, and it's an early reflection for the listeners on the floor, and they can deal with that. Now, at the same time, if you are dealing with a back wall that we discussed earlier, imagine this same type of diffusion on a back wall, and you have pyramidals or you have arcs on the back wall that causes the sound to diffract and scatter across the room. It's very useful, and it's a nice way to take care of a flutter problem. If you happen to worship in an auditorium that isn't a rectangle, but it's a fan, the idea of taking care of the rear wall becomes very, very critical. Sound is focusing right back to a central point in the room, and you end up with all this energy showing up at the pastor. One additional problem that you have with a fan-shaped auditorium is that the energy from the choir doesn't reach the listeners properly. A lot of that energy is dependent upon the sidewalls of a small room to reflect and then go back to the listening area. When you move the sidewalls out, as in a fan, the energy hits the sidewalls, but now it goes only to the corners of the room. And the people sitting out there might hear well, but the people sitting in the center of the room don't hear very well at all. So we go back to our same principle. We try to change the shape of the back wall. As you notice in the drawing here, the back wall has been serrated. The energy hits the back wall, but then is scattered throughout the seating area. And this allows the sound to create more of the room to have more of a natural sound. If you took a real close look at that back wall, one thing is important. The angles used at the back wall are not one series of symmetrical angles. They're various angles, and the result is that it allows the sound to go to multiple locations within the space. It's not just a single set of angles. Also, you notice that a lot of times architects prefer a smooth aesthetic look. And so what you can do is stretch a breathable fabric over the entire front of all of those angles, and you still have visually, it creates the same image. But that cloth that you use to stretch across it must be an acoustical cloth that's breathable so that the sound can pass through it uninhibited. The reason for us to include this section on the tape is so that you have a basis for understanding some of the principles of how sound reacts in a rectangle or in a fan, because those are primarily the two major types of construction that we see in churches that operators have to deal with. It may be necessary for you to get the advice of an acoustical consultant on your room to help take care of some of those problems. It may also be that you're going into a building program and you, the operator, can get someone involved in the design process to help take care of these problems so that you won't have to face them. Regarding contemporary worship, is there a best or a better way to place the instruments up on the stage area, such as the vocals, the drums, the keyboards, an arrangement that works optimally at all times?
In contemporary musical groups that are part of the worship service, one of the sound operator's biggest challenges is learning how to negotiate with the musical director or the group itself, because oftentimes where the musicians or the players want to be is not the best place for you from a sound operator's perspective. Ideally, the thing to do is take anyone whose instrument creates noise naturally, like a drum kit or a bass guitar amplifier, a keyboard amplifier, and keep that as far as you can from any instrument or vocalist who requires a microphone to pick up what they do. So you want the noise sources separated from the noise pickup device. That means anyone who is creating noise, bass guitar, drum set, guitar amp, what we call the rhythm section, typically will try to cluster or group them together and then create some sort of space or distance between a vocal group or a vocal soloist who is playing with them but is needing a microphone. If you have an acoustic piano, an acoustic guitar, you're always better off to try to go for a direct pickup format, a pickup built into the body of the guitar, for example, or one of the small miniature microphones closely attached to the guitar body that we've talked about, rather than expecting an area mic to pick up just that acoustic instrument. So the physical location of the people in the group is something you work out and negotiate with the group members, and a benefit for you that is also something to keep in mind is if you place the people correctly so that the instrumental players are close to each other, they hear themselves naturally, and you don't have to feed the signal from their guitar amp, their bass amp, their keyboard amp into a monitor system, because the more monitors you put up there, the more noise you have at the front of the church in this reflective shell area that was usually typically designed for acoustical music, and the more problems you start to have creating a mix or a blend of these instruments and voices.
If I might address that also, if you do not have the physical space to move the electronic instruments, or let's say in some cases if you're dealing with orchestra and you've got bands or trombones or some brass, that there are barriers that can be done acoustically where you put them up in front of them and they have absorption and they will help pull down some of their sound.
Is feedback the result of direct mic-to-speaker interaction, or can it result from reflected sound off of the walls and ceilings?
My question, right?
Your answer.
I get to answer that? Yes. You know, the problem with that is they're both true. If you stand in front of a speaker, and let's say we were using this particular microphone that we started with, this microphone has a wider pattern of pickup. And if you stand in front of a floor monitor, you're likely to hear the floor monitor in the mic, and so feedback could be a direct result of the distance between the speaker, loudspeaker on the floor, and the microphone itself. But sometimes I can simply change microphones, and I go to a microphone with a tighter pattern. Now I don't have that problem. So you think, well, that's one way that it's directly a result of the speaker to microphone relationship. At other times, if it's the podium mic, you can't change it very often. It's designed into the room. But we have a curved back wall, a lot of energy focused back to the pulpit, and now we have a very large feedback problem. How do we address that? You can't address it by changing the mic. You can't address it by changing the speaker system. That's something that must be addressed by changing the geometry of the room. All miniature condenser microphones apparently need voltage sent from the mixer. Now, is this normally a 48-volt signal, or is it more or less?
Typically, the condenser mic uses what we call phantom power. And it's called phantom power because it exists in your microphone lines coming from either the mixing console or from a small auxiliary power supply that does give a voltage output. 48 volts is the standard. Most modern condenser microphones will work with as low as 24 volts supplied to them, and if you get up above 50 to 54 volts, you're starting to give it more than would be healthy for the microphone element. But 48 is the standard, and what we call phantom power, 48 volts, that is usually a supply source found on your mixer. If you don't have that, but you do need to use condenser microphones, small auxiliary phantom power sources are available from several manufacturers.
He high and wide spoken, cleft of the rock, where